Hi class, let's take a look at example 2. Now, example 2 has a couple of inequalities that we need to solve, and one of the rules that we have to take into account as we solve inequalities is if you end up dividing or multiplying by a negative value, you simply switch the inequality. So let me do, the second example has a negative, so this only applies on divisions by negative. Now, on problem 1, you simply have 2x is greater than 10. So we're going to divide by 2 and by 2. And in this situation, we end up with x is greater than, well, technically 5, which happens to be our solution. Notice that we divided by a positive 2, so there's no switching of the sign. So we just end up with the values of 5. And the instructions are to solve and graph. So I'm just going to say that this is 0, 1, 2, 3, 4, 5. And we're looking for a statement x is greater than 5. I'm going to put the open circle on this one. You can put the open circle, the parentheses. I'll use both of those notations. And then greater means it goes to the right hand side. That's going to be our actual solution for the graph. And in this case, this one happens to be 1 like the previous ones. Let's take a look at problem B. And same instructions, they're asking for us to solve and graph. But we do have a minor problem here. When we take care of the division of the negative 2, we're supposed to flip the sign. So notice that the inequality reads negative 2x is greater than 10. So you're going to end up with x is less than negative 5. And once again, after the division, you flip it. And, well, oops, let me just put 0 around the middle. 1, 2, 3, 4, 5. And the statement says less than. So I'm going to use the parentheses. And that's pretty much it on this one. Notice once again on the previous one that on problem A, there was no division by a negative. So the inequality symbol, we ended up with a greater. So that means that you end up shading to the right. B, we ended up dividing by a negative. So a greater turns into a less than. Let's move on to C. In problem C, in order to solve, we're just going to have to multiply by 4 and by 4. And on the left hand side, the x's cancel. You end up with x is greater than 4. And notice that we multiply by a positive value, so no need to switch the inequality. So this is 0, 1, 2, 3, 4. And it's also a greater, so let me use the open circle. And greater means every value towards the right. That's actually it for C. It requires a multiplication of 4. Let's move on to D. And notice that D, we're going to have to multiply by negative 4. So what this is going to do is, on the left hand side, you're going to end up with x already isolated. And the greater, because we're multiplying by negative 4, it's going to turn into a less than negative 4. And once again, this is 0, 1, 2, 3, 4. And let me use the parentheses. And less than means to the left. Okay, that's actually it for D. I just wanted to do a quick example on why this rule applies. Notice that we're multiplying by a negative in a statement that originally read greater ends up with a less than. And let me just do a quick example here. Let me put it in green because it's not part of this problem. Now, notice that if you have the values of 2 is actually less than 10. And if you divide 2 by a negative 1 and divide by a negative 1, you would end up with, if you don't flip the inequality, with a statement that says negative 2 is less than negative 10, which this is actually false. If you look at the number line, this is 0, this is negative 2, this is negative 10. So numbers to the right are larger. In this case, in order to make the true statement, we will simply say negative 2 is greater than negative 10. So it's easier to visualize with numbers, but keep in mind that what we technically have on all of these inequalities is statements with variables. And I'm talking about, on this one, these two values. Numbers to the right are larger than numbers to the left. So if you don't flip it, you would end up with negative 2 saying less than negative 10, but negative 2 is greater. Therefore, you would adjust it to make it into a true statement. And this rule is a little bit hard to visualize, especially because you're looking at variables. That's actually it for these set of problems. Once again, one of the main rules that shows up on solving inequalities is if you end up dividing or multiplying by a negative value, you simply switch the inequality. If it's a greater, this one greater, you're going to end up with a less than.